Hola, mi clase. Here we go. First note taker of the year. We are on Unit 1. This is going to be talking about and covering lessons 1 through 3 from the past couple of days. So our objectives have been, I can describe and use a sequence of transformations to move one figure onto another. So these vocabulary terms, if you notice on your note takers, they're there, but they're not written out for you. So what you need to do is open up your flap, lift up that note taker, and on the page underneath, you need to copy down the word and then the definition. So you're going to lift up your flap, you're going to write down transformation, and then you're going to write an action or rule for moving or changing figures on a plane. That's what we've been doing. Okay, so copy that down. You'll need to copy down all the vocabulary words and their definitions. So you're going to definitely need to pause, get them copied down, and then push play. So the second vocabulary is sequence of transformations. It's a set of translations, rotations, reflections, and dilations on a figure. We haven't done dilations yet, but when we do, it's all 4 of them, but we've done translations, rotations, reflections. So the first one's a translation. This moves every point in a figure a given distance in a given direction. So they have to give you the distance, 1, 2, 3, 4, 5, and they have to give you the direction, left, right, up, down. Reflection, that's where we cross a line, right? Crosses a line, moves every point on the figure to a point directly on the opposite side of the line. The new point is the same distance from the line as it was in the original figure. So if it was 3 to the left, it's on the opposite side, so 3 to the right, opposite. Rotation moves every point on a figure around a center by a given angle in a specific direction. And then those directions are counterclockwise. It's the opposite direction as the hands of a clock, so to the left of a turn. And then clockwise is the same direction as the hands of a clock, so to the right of a turn. Make sure you have those. Get them copied down. We need to know what these terms mean. So we are going to do some problems that are review. These are for frequency problems. And so it's just so that we have reminders of things as the year goes on. So problem number 1 through 3, we're going to determine whether each value of n makes the inequality 2n minus 5 less than 13 true. Or does it work? And then we're going to write yes or no. So as a reminder, right? So it says n equals 8. So we're going to take 2 times 8 and then minus 5, and we want to know if that's less than 13. So we get 16 minus 5 less than 13, and then 16 minus 5 is 11 less than 13. And because 11 is less than 13, we can say yes. This is substituting, right? We're making n become a something else, inputting it. So 2 input 9 minus 5 less than 13. 2 times 9 is 18 minus 5 less than 13. And then 18 minus 5 is 13 less than 13. 13 is not less than 13. It's equal to. And so we would say no. And then last one, input, we're going to go 2 input 10 minus 5 less than 13. 20 minus 5 less than 13. We get 15 less than 13. That is not true, so we say no. All right, you're going to go to the next flap. Oh, nope, I'm sorry. You're just going to continue down. We're going to do problems 4 through 7. So I'm going to do my work off to the side. You might want to as well. There's some space over here, right? So I'm going to do number 4. Remember, with multiplying, we want to take the one with the larger digits and start with it. So we're going to go 2 4/10 and multiply by 5. Remember, when there's no operation, it always means multiplication. Operations that don't show themselves are always multiplication. So 5 times 4 is 20. 5 times 2 is 10, plus my 2 that we carried from the first time is 12. Now remember, numbers behind the decimal, we need to find out how many there are. There's 1. So we move the decimal over back to the left once. Also, we have 1, 2 negatives. So when we have a negative times a negative, it becomes a positive. This was something we learned in Module 1 last year. And so a positive 12 would be our answer. Okay, let's do number 5. Negative 7 4/10 divided by 10. So we're trying to split 7 4/10 into 10 pieces. That's what it means. And how much would be in each piece? So 10 on the outside, 7 4/10 on the inside. 10 does not go into 7. So I put my 0 and I bring that decimal up, straight up. Fix that little arrow, fix this decimal. There we go. 10 goes into 74 7 times. That's 70. We subtract 4. We add a 0. We bring it down. 10 goes into 40 4 times. And since I got 0 at the end, I am done. And then I go back and look. Oh, I have 1 negative. A negative times a positive is a negative. So it's negative 74 hundredths. All right, number 6. Negative 4 over 7 divided by negative 2. Remember, we need to make all whole numbers into a fraction by putting it over 1. We're dividing by a fraction, so we need to leave this one alone and then multiply by the reciprocal or the flipped over version of our second fraction. So we're going to go, I'm going to leave the negative 1 over 2. We multiply straight across. So negative 4 times negative 1. Well, a negative times a negative is a positive. We just reviewed that in number 4. So we get 4. And then we get 7 times 2, and so we get 14. We always must reduce, so I can reduce this by 2. And we get, I'm going to put my answer over here, 2 over 7. All right, number 7. Again, I'm going to make my 4 over 1. All fractions, if I have a fraction, I need to make sure everything's a fraction. This is just multiplication, so I'm going to go 4 over 1. I don't need to change anything, and I get to just multiply across. So 4 times negative 3 is negative 12, because it's a positive times a negative. We reviewed that in number 5. And then 8 times 1 is 8. We need to reduce. This is our multiplication chart. I'm going to reduce them both by 4. And I'm going to get negative 3 over 2. Alrighty, this is where you're going to go to your next page. Frequency continued. It says write an operation in the box to make each equation true. So we have 12 something minus, or negative 8, I don't know why I said minus, 12 something negative 8 equals 20. So I have a positive and I have a negative, but I really need them both to become positive. So if we remember from module 1, when we subtract a negative, it turns into a positive. Because remember, I'm going to rewrite it here. We add the opposite. And so now I have 12 plus 8. And now I have 20. It created the 8 to become positive, which is what I needed. 2 numbers being positive because I needed a positive answer. So for number 9, I have negative 17 and positive 9, but I have a really big negative number. I don't have enough negatives yet. So I have negative 17. I need more negatives. So I'm going to subtract. And actually the same thing happens. So negative 17 minus 9. Oh, that is not a 9. Excuse me. If I add the opposite, you can now see the negative 9 is also negative. So if you have negative 17 plus more negatives, 9 more negatives, they will make negative 26. So the last one is 24 and negative 29, and then I have negative 5. So I have a really big positive number, I have a really big negative number, I want a small negative. So I don't want more positives, I don't want more negatives. So because I don't want more of one of them, I'm just going to add them together. 24 plus negative 29. The reason this comes out as negative is because you have $24, but you want to buy something for $29. You subtract them. So I'll do that over here. 29 minus 24. Remember, we subtract them when they're opposite signs. I get 5, but because I have more negatives than positives, it becomes negative. Or which one has a greater absolute value? That's what we talked about in module 1 last year. And 29 has a greater absolute value than 24, and that's why my answer is negative. All right, last problem. So this is a little different. This is called our test practice. So these are what kind of your questions for your test will look like. This is the stuff that's really going to be on your test. So this would be a great thing to star or highlight, because this is where you really want to concentrate and study and look over and make sure you really understand, because this is what's going to be on your test. All the stuff up above is all review to help us with this year's concepts. So if we remember the things up above, they will help us throughout the year to be successful. So we've been doing transformations and sequences of transformations where if I do certain ones, they will allow me to move my figure. I can combine them. So it says select all the sequences of a transformation that would return a figure to its original position. So it says reflect the figure over a line and then reflect it back over the same line. So I take it and I flip it. It's the same distance on the other side. But then when I flip it back over the exact same line, it's just going to end up the same distance. So if it was 2 away, it's 2 away. And now I'm telling it to go back, and now it's still 2 away. So that is definitely one of them. So next one says translate the figure 1 unit to the right. So I'm going to draw a number line because that kind of will help us since we're going to right to left. Okay, so let's start at 0. I'm going to go 1 to the right. Okay. Here I am. 4 to the left. 1, 2, 3, 4. Oh, there we go. Then it says go 3 to the right. Well, if I'm right here, right on this spot right here, If I go 1, 2, 3, you can see I end up right back where I started. So yes, this will definitely end up at the same place. Reflect over one line and then reflect over a different line. So if we said the first one worked, we could definitely just say this one doesn't work because it's a different situation. But also, if I reflect over one line, let's say from left to right, and it's 2 away, from left to right, but then I want to reflect up and down, that's a different line. That will not end up in the same place. Or if I go reflect left to right over one line, say I'm 2 away. If I go over a different line, I'm at a different distance than when I started. So this will not work because now it's a different distance from when I started. All right, rotate a figure counterclockwise around a point. Okay, I'm going to draw a clock. So remember, a clock can be split into 4 pieces like this, and they all make 90 degrees. So it says counterclockwise. I'm going to pick a different color really quick. Oh, sorry about that. 90 degrees. So that means if I do it like a clock, I'm going to end up here. And then it says, then 270 degrees still counterclockwise around the same point. So this is my point, right? It's the middle. It's going to draw. There we go. There's my point in the middle. So now I'm going to do 270 degrees counterclockwise, same direction. Okay. So here's 90, 180, 270. And you can see I ended up at the same spot. Okay, so that one will work. All right, I'm going to draw another clock. Change colors back to black because it'll look better. So I'm going to draw another clock. So we're rotating again. That one's not so pretty, but that's okay. Split it into my spots. Rotate. So we'll put this as my figure. Here's my center. Okay, so it says rotate the figure 90 degrees counterclockwise around a point. Okay, so it's the same thing, ends up right here. That's counterclockwise. And then 270 degrees clockwise around the same point. So clockwise is this way. So 90, 180, 270. I definitely did not end up in the same place. So that one will not work. And we're done. So make sure you have everything. I think drawing these pictures will be really helpful so that you can study and understand why they're correct. But remember, these are the ones that we really want to make sure we understand about why, or be ready for the test. All right, until next time, adios.